Here's a look at confidence intervals and prediction intervals in regression. It took me a long time to finally understand confidence intervals and prediction intervals in regression because the terminology almost sounds like a riddle. If you carefully study this video, I believe you will have a good grasp on the concepts. The sample regression line is a point estimate of the population regression line, and the population regression line shows the average value of y given x. Confidence intervals are estimates of the average. Individual observations of y could be higher or lower than the average, that is, above or below the regression line. Prediction intervals, on the other hand, are estimates of y for individual observations. Prediction intervals are always wider apart than confidence intervals because individual values of y vary above and below the average value. This can be confusing because it sounds a little bit like double talk, but I think the next example will clear things up. First, I'm going to create some data and run a regression with the data. Let's take a look at each line. Line 5 uses the RUNIF function. That's R uniform. There are 3 arguments. The first argument is n equals 100. This is the sample size. The second argument is min equals 10, and the third argument is max equals 100. This line of code selects a random sample of 100 observations from a uniform distribution. That's a horizontal probability distribution where all observations have the same probability of being selected. The minimum value is 10 and the maximum value is 100. The data are stored in an object named x. Line 6 sorts the data from low to high. This makes a plot I'm going to use a little better. Line 7 defines the population regression equation. The intercept is 10, the slope is 2, and the error is 100 random observations from a normal distribution with a mean of 0 and a standard deviation of 50. This information is stored in an object named y. Line 8 creates a data frame containing x and y, and the data frame is stored in an object named d. Line 11 uses the LM function to perform a regression analysis with y as the dependent variable and x as the independent variable. The regression output is stored in an object named fit. On this slide, I find the confidence and prediction intervals. Line 14 selects 100 observations from a uniform distribution and stores the data in an object named ND. We will find a confidence and prediction interval for each of these 100 observations. Line 17 uses the predict function to find the 99% confidence intervals. The first argument is fit, the object that contains the regression output. The second argument, interval equals confidence, specifies confidence intervals. The new data argument defines the data to be used, and level equals 0.99 defines the confidence level. Line 18 uses similar arguments to find prediction intervals. Lines 21 to 24 plot everything on the same graph. The regression line based on the contents of the object named fit is shown in red, the confidence intervals are in blue, and the prediction intervals are in green. This slide shows the regression line. Here's how to interpret the intervals. We think the population regression line is somewhere between the 2 blue lines, which are the confidence intervals. Notice these lines are curved. They're closest to the red line at the mean of x and get wider as you move further away from the mean. We think most of the individual observations, that is the individual data points, will fall between the 2 green lines. They, of course, are the prediction intervals. In this particular example, all of the data points are between the prediction intervals, but one is almost outside of the prediction intervals, and I've drawn a red circle around it. Thanks for watching, and please let me know if you have any questions.